Hello everyone. I'm gonna give today homework 1.4-11. Okay, so as it's given here, we have a crate with weight of 150 pounds. The weight of the tailgate is 60 pounds, and the tailgate is supported by two cables. The effective cross-sectional area of the cable is, as we can see, the area effective of 0.017 inches square, and the tensile force in each of the cables is D. Now, because there's two cables, we put this tensile force as 2T in this graph. Okay, the weight of the tailgate is going to be 60, because what we're doing is kind of like a side view of the 3D diagram. Here, there's going to be a reaction force in the y direction and a reaction force in the x direction in the hinges of the tailgate, and obviously the crate is going to have its own weight. Okay, perfect. We have the dimensions here: 18 inches, 14 inches, 16 inches, and all the letters. Okay, so from the figure, first we need to calculate what is that angle theta. That angle theta we calculated by getting the lengths 12 and 16 from the graph, this triangle, and we find the arctangent of this angle. So the arctangent of 12 over 16 would be 36.87. which we will have down here. The arctangent is this angle. So now we have the angle of inclination between the tension and the tailgate. Okay, now we need to find this tension. In order to do that, we need to use some of the moments about that line. The line would be the hinge A, because we are looking at the side view. We're going to use the sum of the moments of these. So we have the weight of the tailgate, right, which would be 60 applied here in the middle, the weight of the block here in the corner, right, times 18, because it's the distance from the hinge to the center of this weight. And we're going to have the y coordinate of these 2t, that would be the y coordinate of the tension multiplied by 16, because it's the distance from this tension to the hinge A. So we will have the following. Perfect. Why is it negative? Because it's going clockwise. If we're looking at this hinge, this weight is causing a clockwise momentum from the hinge. This tension is causing a counterclockwise momentum, so that's positive, and this weight is a clockwise momentum as well. So we multiply the forces times the distances, and we do all the math, and we find that the tension of the cable, of each one of the cables, because there's two cables, one in each side of the tailgate, is going to be 184.37 pounds. Okay, that's good. Now we continue finding the normal stress at each of the cables. We know that the normal stress is the tension divided by the effective area. Okay, we have from this problem that the effective area is 0.017 inches square. So we just need to divide this tension that we just calculated by that area. So by making the operations, we find that the normal stress, okay, wait a sec please, it's taking a little bit longer than I thought it would. Perfect. So we have it here. The normal stress in each cable is going to be the tension divided by the effective area, which is 184.37 divided by 0.017, which would be 10.84 KSI. Perfect. Now we need to find the elongation of the cable. The elongation is how much the cable has stretched in this because of these weights and these forces. So we have the elongation. Oh, sorry. I'm kind of mixed up right now. We have the elongation of the cable that is 0.01 inches, and we have the original length, and we need to find the strain of the cable. Perfect. So we know that the strain of the cable is the elongation divided by the original length. Okay, and I'm gonna put that here. The elongation of the cable is 0.01 inches, and the original length of the cable is this, that is the hypotenuse of that triangle, 16 squared plus 12 squared divided the square root of all of that, and the strain of the cable would be the elongation over the original length. Okay, by making all these operations, we find out that the strain of the cable would be the deformation, as I said, divided by the length, and would be 5 times 10 to the negative 4. It's adimensional because the strain is always adimensional, is the division of two lengths. Okay, with that we finish problem 1.4-11. Thank you so much.